All right, everybody, it's time for the finale of the year, the comprehensive exam review book, study guide, whatever you want to call it, key to success. Let's start with chapter P. Without further ado, busy, gotta go. Okay, so something that will help us throughout, interval notation. Interval notation says we can write the location of a unknown variable using inequality, or we can use this concept of a smaller value, 9, going to a bigger value, and then we use square brackets if it could equal that value and curve brackets if not. So we've got A for our first answer. All right, types of numbers. Which does not ensure that a number is rational? So rational, by definition, you have to have A over B, or A, B, both integers, and B is not equal to 0. So A does make sure it's rational. And then B and C are two other ways that you can know you have a rational number, such as 0.1 repeating is 1/9. That would be that one, sorry. Or 0.1 terminating means ending, be 1/10. Solution to a quadratic equation, though, doesn't have to be rational. For instance, x squared equals 2 is a quadratic equation, and the solution would be plus or minus square root of 2, and those are both irrational. Which of the following numbers is rational? Okay, so that's rational, 22 over 7, because it is a ratio of two integers. This is rational because it's a terminating decimal. Sorry for the anime music in the background. Okay, this is a little bit tricky because usually square roots we say are irrational, but look at this. This is square root of 1 over 4, which is square root of 1 over square root of 4. Since both of those are perfect squares, if you can write it as a ratio of integers, then it's rational. Therefore, square root of 32 is irrational. Right? Square root of 32 can be simplified to 2 square root of 2, but it's still irrational. Okay, given 2 points, what is the length of the segment? We could draw a sketch, but I'm just going to go straight to it. Length is a distance, basically synonymous. So if you go here, you could find the distance between them. So distance formula, subtract the x values, square them, plus subtract the y values, square them. Yeah, just be careful with your subtractions, the main thing you gotta worry about. So you get -7 squared plus 3 squared. You've been doing that for years. Just be careful when you do so. Square root of 58 sounds good. And I'm probably gonna have to take a break here. Okay, let's look at midpoint formula. So midpoint, we got the same 2 points, so I might as well draw a sketch. So what do we have? We've got A is -4, 2. Something like that. B is 1, 2, 3, -1. Something like that. So, right, so remember the whole point of the distance formula is that this is 7 because if we draw this, the horizontal distance between A and B is 7. The vertical distance is 3. So this 7 squared plus 3 squared equals, boom, square root of 58 squared. But what is this asking? Midpoint formula. Midpoint's asking for a point in the middle of these two. So I'm going to eyeball it. It should be right here. If you have a sketch, you can basically get the answer right now. As long as your sketch is somewhat accurate, it should be in quadrant 2 here, negative, positive. In between these, it should be this, but let's verify. So midpoint formula, we take the two x values and add them and divide by 2 because we want to find the middle of them. We're finding the average of the two x values and the average of the two y values. And so we get -1/2, comma, +1/2, which is in fact A. This is all review stuff even from, algebra 2, algebra 1, but just be careful with it. Okay, the endpoints of a diameter of a circle are this, that. So how do we do that? Well, again, let's just take a moment to draw a sketch. So we've got -3, 1, 2, 3, 2 here. 5, 6, 1, 2, 3, 4, 5, 3, 4, 5, 6, something like that. Now, if this is a diameter, then the circle looks something like this. Of course, that's a little bit distorted with my drawing skills, but anyways, so remember, for an equation of a circle, we want two things. We want the center of the circle and we want the radius of the circle. So really what we need to do is find the midpoint. Midpoint is add the two x values, divide by 2, add the two y values, divide by 2. So we get 1, 4. So we already know that it's not these two. We need 1, 4. And then to find the radius, we need the diameter divided by 2. So the diameter is going to be, apply the distance formula here. -3 minus 5 squared plus 2 minus 6 squared is 8 squared plus, be careful here with your negatives, -4 squared, so it's rad 64 plus 16 rad 80. This is the diameter. So we can simplify this to say this is, well, this isn't even going to be fully simplified, but we can do this. One of the perfect square factors is 4, so it becomes 2 squared of 20. So now we can divide it by 2 and say the radius is square root of 20. So remember, in the circle equation, it's x minus h squared plus y minus k squared equals r squared. So square root of 20 squared is 20. It's B. Okay, solve the inequality. Okay, so the way I do absolute value is split. Absolute value means two things. It either means x if the inside is greater than or equal to 0, or it's the opposite if x is less than 0. So what we have here is two possibilities. If the inside here is positive, then we just have this, 2x minus 5 less than or equal to 3. That's just one possibility, though. The other possibility is if the inside is negative, then we have this. We want to take the opposite of it. So, okay, let's solve. We've got two separate things here. We've got 2x could be less than or equal to 8. Or 2, if we multiply both sides of this by -1, we switch the sign to get -3. Which, by the way, some people just go straight to that, right? 2x minus 5 is either less than or equal to 3, or it's greater than or equal to -3. Add 5 to both sides. 2x is greater than or equal to 2, x is greater than or equal to 1, or x is less than or equal to 4. So less than or equal to 4 or greater than or equal to 1 is between 1 and 4. Always put, if we want to put this together, we put the small number, big number. And you're bigger than that, less than that, so it worked perfectly as a nice interval. And you can equal it because it's less than or equal to. Okay, what does this look like? It looks like we ran out of space because we're going to need to complete the square. Completing the square is easiest for circles. You did this in algebra 2. It's easier. Remember, a circle is a conic section. So it's just like for an ellipse, hyperbola, etc., but easier because it's got no coefficient. So we can just get straight to completing the square. And so that's going to make things a little bit easier in the end here because we're just adding 9 And here we are adding a 25. And so what we have here is 49. And look, there it is. Oh, wait, that's not there it is. That's, oh, let me switch out this pencil here. This pencil's not good enough. Celebration pencil. Okay, so we've got the center here is 3 comma negative 5. That's already our answer, eh? And then remember the radius squared is 49, implies that the radius is 7. Okay, solve the equation. Watch, we could expand this, but watch the trick. If you got the same thing on both sides, watch what I'm gonna do. Oops, it's like we've got 5 of these things. We got 6 of these things, we're subtracting 5 of these things. 10 equals 1 times x minus 1. So x equals 11. Cruising. On a test, you plug back in to verify. Solution to this inequality. Okay, here's something nice about these compound inequalities. Notice that they're going in the same direction. This is smaller than that, this is in between. We can keep it together and just multiply everything by 3. You get negative 9. If you're multiplying by a positive, don't worry about switching anything. 3's cancel out. And then 5 times 3 is 15. That means we can make our work nice and compact. And here we go. Again, we're dividing by a positive, so it is no worries about switch anything up. And be careful with your symbols, less than or equal to. Okay, and then finish off the page. Remember the concept here. Like, it goes back to what I said up here. Absolute value means 2 different things. It's a piecewise function. If the thing inside is already greater than or equal to 0, you keep it the same. But if it's negative inside, you switch to its opposite. So the first thing here is to note that square root of 3 is greater than 1 because it's greater than square root of 1, right? So it's greater than 1. So that means, therefore, 1 minus square root of 3 is going to be negative. You're doing something smaller minus something bigger. So what that means is that this is equal to the opposite. Therefore, it's equal to negative 1 plus square root of 3, which is actually this, right? Because we could, commutative property of addition, we can do like that. Wait, what? Oh, man. Come on, good thing I got this nice eraser here. So, basically, right, if the thing inside is less than 0, you take its opposite, which means you can kind of switch it around like that. All right, let's get into lines. Which of the following is a line that passes through this point and is perpendicular to this? Okay, so it looks like all our choices are in point-slope form. Point-slope form looks like this, where you have a line with slope m and a point x1, y1. Notice the similarity with like the equation of a circle. It's got the x minus, y minus. So if we have the point 3 comma negative 2, the big thing to be careful with is, of course, this is the y value. So it's y minus negative 2, and then it's x minus positive 3. So we already kind of know it's going to be A or C. Now the slope, we need it perpendicular to negative 1/2. So the original thing was negative 1/2. We want it to be perpendicular. We want it to be the opposite reciprocal. So we want the slope to be positive 2. Throw a 2 in there. And therefore you got A. So this line would be parallel to the original through that point. We want perpendicular to the original. So that's point slope form. Now this is kind of similar to general form, although I think general form is usually like this. But anyways, right, there's two ways we could do this. To get this to, we want this little slope, right? So we need to find a slope. Well, we just solve for y, so let's just do that. Negative 3y equals negative 2x plus 4. You know, do what you're comfortable with doing. You know, on an exam, you got plenty of time to do this. Just take your time. So the slope is 2/3. So this one is parallel. Now, there is another way to do this. If you got standard form, this, which is ax, oh, excuse you. Oh, my, which is this. The slope is negative a over b. You know, could be helpful to memorize that, I suppose. So our slope should be negative 2 over b. Negative a over b, so it's 2/3. General form, slope. Okay, which of the following is the solution to the equation? What are we doing? Back in Algebra 1, I suppose. Okay, we could always do quadratic formula. But I think this guy should be able to be factored. I'm going to do my factoring trick. Multiply these, you get negative 6. What are the factors of negative 6 that would add to negative 5? Well, already I got it. Negative 6 and 1. So I can split this into 2x squared minus 6x plus x minus 3 equals 0. Factor from these two terms, I get this. Factor from this, a 1. And if I get the same two factors here, there we go. 2x plus 1 is x minus 3 equals 0. So, I mean, Algebra 1, we can already see the answer, but let's do this. Let's say, okay, so the 0 here is, the zeros here are x equals 3 and x equals negative 1/2, okay? Now, this is not necessary for this problem, but, you know, I'm going to be extra here, and I'm going to say, what do we have here? We could put these on a number line and say, okay, here's 0, here's 1, negative 1, rather. So at negative 1/2, it's equal to 0. At 1, 2, 3, it's equal to 0. And because its leading coefficient is positive and its degree is even, we've got this, don't we? We've got end behavior going up. We've got each factor here is multiplicity 1, so it crosses, and there we go. So that was a waste of time because we just want to see where it's equal to 0, but still interesting. So it equals to 0 at negative 0.5 and 3. What is the value of I to the 207th? Okay, remember this trick. It's about the pattern of i's. By the way, remember we do have some useful stuff here. Eventually, that might be helpful. So here's how you can do this. I to the 207 is equal to I to the 200. Oh, watch this. It's I to the 200 times I to the 7th, is it not? That's how exponents work. Well, I to the 200th is I to the 4th to the 50th, is it not? So what do we have here? I to the 4th is, I believe it's 1, isn't it? Correct me if I'm wrong. So you get 1 to the 50th times I to the 7th, which is 1 times I to the 7th, which is, yeah, you guys wanted to get to this 2 minutes ago. It's negative I. And here's a tricky one, but it's not that tricky once you realize what's happening. It's just a multiplication. How do you solve a multiplication? Divide. 74 over 7 plus 5i multiplied by the conjugate to get rid of the denominator. And you have 74 times 7 minus 5i over 7 times 7. Well, we've got a difference of 2 squares. First thing is the same, that's 7 squared. Last things are opposites. So we've got 74 times 7 minus 74 times 5i Is the right answer going to be here? I don't know. Over 49 minus negative 5. Well, this is kind of weird. Which is 54. What? Did I do this right? Oh, it's 25. Sorry, my bad. Minus negative 25. Okay, that'll be nicer, right? 5i squared is 25i squared, which is negative 25. Okay, so you get 74. I'm going to factor this back out because look what we get. 74's cancel. 7 minus 5i. I mean, when you think about it, this is basically asking, what can you multiply this non-real number by to get a real number? It's got to be its conjugate. Otherwise, you're not going to get a real number. Tricky way to ask that, though. Okay, let's finish this off. We're almost there. What is the solution to this inequality less than or equal to 0? First of all, realize it's just asking about a polynomial inequality, so we need to find where it equals 0 and then sketch it. So I'll factor this right quick. Again, on a test, you're going to be careful to say negative 1 times negative 3 is positive 3, negative 1 plus negative 3 goes negative 4, but we're good there. So where does it equal 0? It equals 0 at 1 and 3. So we can sketch this out, and we can say on a number line, at 1, you don't even have to write out these little tick marks, but I did here. It's equal, f of x is equal to 0 at 1, x equals 1, and x equals 3. This is the x-axis. Just sketching it. And this is a parabola, positive lead coefficient, even degree, crossing. So what do we have here? Parabola. Where is it less than or equal to 0? That means this thing has an output, a y value, less than 0. We're looking underneath the x-axis here. That's why the answer is A. Okay, this one has a typo. Thank you, Jasmine, for pointing this out, or not rather a typo, just a complete error. In the equation below, k is an unknown constant. If the equation has two non-real solutions, what can be determined about k? Well, okay, we've got a quadratic. We know from a quadratic, the thing that tells us what type and number of solutions we have is the discriminant, b squared minus 4ac. So let's plug in there and see why this has an error in it. So b is 4, a is k, c is k. And if we wanted to have non-real solutions, we need that to be less than 0. We need a negative discriminant. So we need 16 minus 4k squared to be less than 0. Solve that. Add 4k to both sides. There you go. Divide both sides. K squared is greater than 4. K squared is greater than 4. K squared is greater than 4. Well, you can think about what's happening there. Or you can actually solve it the same way. If we go like this, and then run out of space here, basically we have k minus 4 times k plus 4 is greater than 0. So we have a parabola again. I misspoke here. X squared or k squared minus 4 obviously has zeros at negative 2 and 2. Not negative 4 and 4. Probably if this is the k-axis. Now we're getting some cool stuff here. Zeros at 4 and 4. It's greater than 0. When we switched it around, we got this greater than 0 on the outside here and here. So none of these answers are correct. It has to be this. This doesn't even, what is this? That's not even a thing. It has to be this. I don't know what happened when this person wrote this. That should be the answer, no? Yeah. Yeah, two non-real. By the way, I don't know. Everybody calls this two complex solutions. So if you see complex solutions, that also means non-real. I call it non-real. Okay, I'll edit that one later. Okay, we're almost done. Let's get to the end of this. Segment AB has endpoints -5k and 7, -5. Here's what I want to do. I want to sketch this. Okay, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Let's call this B. A is -5 something. 1, 2, 3, 4, 5. Now the problem is we don't know what the y value is. We just know it's on this line. But if the midpoint has 1, 0.5, it's somewhere like here, we could say, oh, the endpoint's somewhere up here. But we want to find it exactly, don't we? So, okay, we could have just gone straight to the midpoint formula. So the midpoint formula say add the x values, add the y values, k and -5. K plus -5 is k minus 5. And that has to equal 1, 0.5. Well, yeah, -5 plus 7 is 2 over 2. That does equal 1. This is k minus 5 over 2. We can't simplify that anymore. But we know what has to happen here. Therefore, these two things have to be equal. I'm going to show my work down here. K minus 5 over 2 has to equal 0.5. Just solve it for it as an equation. Multiply both sides by 2. K minus 5 equals 1. K equals 6. And that looks to be right? The y value looks like it's up here. You could also say it's like 1 is the number exactly between -5 and 7. What is 0.5 in between? It's in between 6 and -5. But you can always depend on the formula. Okay, so it's somewhere up here. If 11x minus 12y plus c equals 0 is the line through A and B, what is the value of c? So here we got general form. By the way, you can see again, general form of the line. The slope I said is -a over b. So the slope here is -11 over -12. That doesn't seem right. Oh, it doesn't have to be this line. Okay, sorry. Wait, what? Is this an error? All right, part B. With this change, we've got 11x plus 12y plus c equals 0. The equation of the line through A and B. So we've got your general form of the line. General form of the line, ax plus by plus c equals 0. So as I mentioned earlier, in general form, the slope is -a over b. So negative of the opposite of this coefficient over this coefficient. So in this case, it would be -11 over 12. And we found previously that we go through, well, we could just say we go through 7, -5. So what we can do here is use point slope form to say y plus 5 equals -11 over 12, x minus 7. And then we can get it to general form. So if we go y plus 5 equals -11 over 12, x plus 77 over 12, and we multiply everything by 12, we get 12y plus 60 equals -11x plus 77. And then if we move this 11x over and move this 77 over, minus 77, there it is. C equals -17. Or you know what we could do? Oh, we could just plug this in. and say 11 times 77. Oh shoot, 11 times 7 plus 12 times negative 5 plus c has to equal 0, so 77 minus 60 plus c equals 0. 17 plus c equals 0, c equals negative 17. There you go. Thank you, Confucius.